we need to do is we need to just define coefficient of friction, okay? So basically what coefficient of friction is it is a number that describes the amount of friction between two surfaces, okay? So if you can imagine, for example, like your palms sliding past each other versus maybe a few like pieces of sandpaper rubbing past each other, there would be a very big difference in the friction there, okay? So therefore there would be a difference in the coefficient of friction. The more friction you have, the higher the coefficient of friction, okay? So this is a number that we need to be familiar with this definition, okay? The other words on this page, friction force, air resistance, and tension force, are all terms that we want to make sure that we have copied onto page 1. Okay, so I'm just going to scroll up to page 1 and we can chat through these different definitions. Okay, so this first one, friction force. And you'll notice that we have this broken into two different types of forces. So for friction force, we have FFS, which is a static friction force. This means there is no movement, but you are trying to move something. So for this, I want you to imagine you are trying to push a very heavy object that will not budge, okay? That is friction force, okay? Or an object, or I'm sorry, static friction force. Or an object maybe that is on an incline that is not moving. That would also be static friction force, okay? Kinetic friction force is, yes, it's saying, yes, there is some friction occurring, but we do have movement, okay? So I want to go through an example of each of these and what these look like for free body diagrams. So this first example, we have a box moving to the left, and then we have a motionless box. Okay, so let's do the box moving to the left first. And I'm kind of running out of space here. So I'm gonna make my gravity force arrow and my normal force arrow just super tiny. Okay, so we'll like kind of make believe that we have just like a super light box. Okay, so FG and FN. Okay. I'm just gonna fix that box or that arrow so it looks a little bit better. Just like super short. Make it a little bit better. Okay, and I want these two arrows, the FN and the FG, to be about the same length here because we have no upward or downward movement. We do have movement to the left though, which is why I'm going to have my push force going much further to the left. So I'm going to make myself some space here. Going to drawing and then the white just to kind of erase this line here. And then back to shapes. I'm going to have a long arrow here. And this is going to be my push force arrow, so FP. Okay. My friction force arrow would be in the direction opposite of the object's motion. So since the object is moving to the left, my friction force arrow is going to move in the opposite direction. Okay, so I'm just going to make that shorter because we know that the object is moving to the left, so we know that whatever friction force is happening, it's not large enough to actually impede movement. And I'm just going to label this FFK for friction force that is kinetic friction. Okay, so then for this next one we have a motionless box. So I have gravity force pointing down, and remember, we always want gravity force pointing to the bottom of the page. Okay. And then we want our normal force perpendicular to the surface that the object is resting on. So we have Fg here, and we have Fn here. Okay. And then our friction force is going to be, again, opposite the object's motion. So we want to think here, if the object was going to move, what direction would it move in? Since this object is on a hill or some sort of a ramp, it would move downhill if it started moving. So I'm going to put my FFS arrow pointed up. And I'm making all of these about the same length. Okay. I'm just kind of eyeballing it. Again, I'm not using like a ruler or anything like that. Okay. Like we can tell this FFP or FP arrow is much longer than the FFK arrow here, right? These arrows are all about the same length. Okay, so it's all like kind of approximate here. Okay, so down to the next definition here. We have air resistance. And air resistance is also a frictional force. And for this, I want us to think about any object that is moving through the air. Okay? It's more noticeable at high speeds, but any object moving through the air is going to have some air resistance. Okay? And this is literally the idea of this is you are moving through the air, and as you move through the air, you displace air molecules. The displacement of those air molecules, the air molecules rushing past you, that is the actual air resistance. Okay? So it's always going to be opposite the direction of motion. So if we have an object, so object falling to the ground, for example, just to kind of give us a scenario for this. So this object is falling to the ground. So we are going to have a gravity arrow pointing down. Again, I'm always adding my two little arrowheads at the bottom. FG. I'm labeling my arrow. And then I have F air pointing opposite the direction of movement. So that would mean that my F air is moving up. Okay. For this next one, we have tension force. The best example I can think of with tension force is keys on a lanyard, okay? But really anything that is being suspended from above is tension force, okay? So this is force transmitted through a rope, string, cable, wire, when it is pulled tight by forces acting on it from both ends. This is always directed along the wire, away from the object being supported. Okay, so we have this object that is being held up by two different cables, okay? So I'm going to first, we are on planet Earth, so I'm going to label this FG. We then have our tension forces. So I have one that is pointing in this direction. And again, these are always along the wire. And the other that is like this. So FT, FT. Okay. Anytime FT is being used, it's always going to be very obvious because you're going to be told that it is suspended or hanging, or there will be some kind of clue if it is not kind of readily obvious. Okay, so some objects are always tension force. So like a swing, for example, we all colloquially know that a swing is an object that is suspended with a rope that you kind of physically swing back and forth on, right? Like there are some things that we kind of commonly just know, but for the most part, it will be, if it's not something that's commonly known, it will be detailed.